In the heart of Siberia, a land where snow can bury entire cabins and the wind howls like a ghost, stood a discreet research outpost. The building itself was nothing remarkable, just another drab Soviet structure from the outside. But inside, an unprecedented experiment was unfolding. A small group of researchers, led by a man named Dmitry Belyaev, was quietly challenging the limits of evolution itself. This was 1959, a time when the Soviet Union was still reeling from Stalin's reign. Many scientists had been denounced or exiled for merely referencing Western genetics. Scholarly debates could literally become matters of life and death if they strayed from the party line. In the midst of this tense atmosphere, Belyaev decided to test a stunning hypothesis. Could wild foxes be domesticated, and not over millennia, but within a few human generations? Though Belyaev's official paperwork presented his project as nothing more than a means to improve fur production, the real purpose was far bolder. He intended to breed foxes for a single trait, tameness, while recording the ripple effects on appearance, reproductive cycles, and even their cognitive capacity. For years, genetic theories about domestication had hovered on the fringes of Soviet biology, suppressed by official doctrine. If Belyaev succeeded, his findings would challenge not only political dogma, but also conventional wisdom on how fast evolution could proceed under deliberate selection. A handful of determined colleagues joined him, aware that if their true goals were discovered, they could be branded as subversive. Such was the reality of Soviet science at the time. Nevertheless, they persisted, driven by the conviction that they were on the verge of uncovering truths that extended far beyond fur quality. Little did they know, their experiment would ultimately reshape our understanding of how dogs, cats, and perhaps even humans came to be. One might assume that selectively breeding foxes is a simple matter of choosing those with the plushest coats or the biggest frames. Belyaev, however, established a radically different protocol. He and his team approached each caged fox, offering food and gentle interaction. The question was simple. Did the fox react with aggression, fear, or curiosity? Those that snarled or shrank away were passed over. Those that approached or showed minimal fear were singled out as breeding stock. The first few rounds of selection didn't appear too dramatic. Some foxes were less jumpy, others more amenable to taking food from a human hand. Then signs of change began to bloom. Fox pups in the second or third generation showed markedly lower stress levels around humans. Their ears pivoted forward in curiosity rather than laying flat in alarm. To the untrained eye, the difference might seem trivial, but to Belyaev's group, every small shift was a beacon, hinting at an underlying genetic recalibration. By honing in on tameness, Belyaev anticipated that other traits would quietly hitch a ride. He hypothesized that behavior, morphology, and physiology were intertwined, regulated by hormonal pathways and certain clusters of genes. If one pressed on the tameness lever, other levers in the genome might move in response. At this point, the official record still framed everything as improving silver fox docility to facilitate easier handling. Yet behind the scenes, the team measured cortisol levels, documented ear positions, and noted subtle shifts in coat color or snout shape. Their objective was to witness in real time what typically took thousands of years in nature, if it happened at all. While many in the Soviet establishment remained unaware of these deeper goals, a few scientists grew intrigued. Rumors spread. You know that project in Novosibirsk? Something truly odd is happening with those foxes. Belyaev's lab became a magnet for young researchers curious about genetics at a time when such inquiry was almost heretical. The tension never fully subsided, and with every new generation of foxes, the stakes grew higher. If their progress came under scrutiny, everything could unravel overnight. About 4 generations into the experiment, the first real bombshells surfaced. Some fox pups were born with floppy ears, more reminiscent of a puppy's than a fox's upright triangular pricks. Others started showing patches of white on their fur, a classic sign of piebald coloration. There was no logical reason for these traits under fur farm conditions. Traditionally, silver foxes are prized for their uniform dark coloring, so random white splotches were considered worthless. But for Belyaev, these anomalies were not a liability. They were living proof of his theory. Tameness seemed to coincide with changes in pigmentation, ear structure, and even bone alignment. Researchers noticed some pups sported upturned tails that curled toward their backs, an unmistakably dog-like feature. All these traits were emerging spontaneously, unselected except for their link to a reduced fear response around humans. In documenting these physical oddities, the team recognized a bigger story unfolding. Something about domestication, be it in dogs, cats, or livestock, commonly led to blunted aggression, piebald coats, and floppier ears. Dogs, for instance, often show white chest markings and droopy ears, whereas wolves do not. Now, a parallel phenomenon was occurring in foxes after just a handful of breeding cycles. Evolution wasn't inching along, it was racing ahead. All the while, the fox's behavior was transforming at a pace that defied conventional biology. Within 6 generations, pups often approached caretakers with wagging tails, a trait hardly associated with wild canids. Some let out short, excited yips that bordered on barks, which is extremely unusual for foxes. The once skittish animals now greeted human footsteps at the cage door with anticipation instead of alarm. A simpler way to put it, they acted like puppies. Researchers observed them rolling over to expose their bellies, pawing for attention and whining for petting. It seemed that while most of the world believed domestication was glacial, Belyaev's lab was compressing millennia into a few short years. They tested the foxes further, offering them new toys, new scents, and new people to gauge how quickly they adapted. Time and again, these tamer foxes showed curiosity rather than fear. It soon became evident that these animals were not just calmer. They also exhibited emotional plasticity. They formed bonds easily and grew distressed when their favorite caretakers left. Such attachments echoed the loyalty seen in domestic dogs, suggesting that a direct line might be drawn between tameness selection and the sociability we cherish in our canine companions. No revolutionary project in the Soviet Union of that era existed without conflict. The 1970s brought economic turbulence, forcing drastic cuts in research funding. With meager resources, Belyaev's team faced a wrenching dilemma: maintain a large, genetically diverse population or keep only the most docile lines. They ultimately chose to cull less tame individuals to save funds. Ironically, this intensification of selection pressure accelerated the shift toward domesticated foxes. Meanwhile, a looming sense of danger remained. Officially, nobody was supposed to be unlocking the mysteries of genetics, certainly not to the extent Belyaev's project was pushing. But the fervent group pressed on, meticulously documenting each litter's traits. They concealed these findings within mundane fur breeding reports. At times they sold a few foxes to private buyers to fund basic supplies. These side deals would yield another unexpected twist pet foxes in ordinary households. Though the laboratory environment provided crucial data, seeing how the foxes behaved as home companions revealed even more about their social adaptability. If you gave them space, stimulation, and human attention, they might greet you like a dog at the front door, happily wagging and chirping. This real-world test of domestication left some families shocked at how affectionate and astute their new pets were, though they were still foxes, with sharp instincts and a flair for mischief. As technology advanced, researchers began genetic profiling of these foxes, seeking to understand the underlying mechanisms. It turned out the transformations weren't random quirks. They reflected changes in neural crest cells. These embryonic cells play a critical role in shaping various structures, from pigment patterns to cartilage development to adrenal function. Tameness seemed to stem from toned-down stress responses, and that shift in turn altered coat color, ear shape, and even facial contours. Further DNA analysis hinted that segments of the fox genome resembled genes in dogs linked to sociability and reduced aggression. Another unexpected parallel arose with Williams-Beuren syndrome in humans, a condition known for extremely friendly behavior and distinct facial features. Though the parallels weren't exact, the overlap suggested that domesticating any species might involve flipping genetic switches that dampen fear and heighten social curiosity. Belyaev's unorthodox experiment thus began influencing a wider sphere of science. Scholars of animal behavior, genetics and anthropology all converged on the notion that domestication is more dynamic than previously assumed. Some might imagine that a once wild fox, even if docile, remains too unpredictable for domestic life, yet accounts from families who adopted these foxes told a different tale. One family recounted their fox trotting to the window each afternoon, waiting for school-aged children to step off the bus. Another described how their fox learned to open cabinet doors to fetch treats, a level of problem-solving that rivaled their dogs. These real-life fox owners weren't part of a controlled experiment, but their testimonies bolstered Belyaev's core argument. Taming is not merely about avoiding aggression, it also reshapes how an animal learns, socializes and communicates. The foxes recognized individual humans displayed excitement at mealtime and engaged in playful nips or barks that closely paralleled puppyhood games. Belyaev passed away in 1985, never fully witnessing the global impact of his life's work. His colleague Lyudmila Trut, along with other dedicated researchers, carried the flame. When the Soviet Union collapsed in 1991, government support for research projects plummeted. Labs that had once thrived struggled to keep the lights on. The Fox project could have vanished then and there, but it endured, thanks to the sheer tenacity of those involved and occasional help from private sources. Some researchers propose that humans might have undergone a form of self-domestication, favoring group members less prone to aggression, more open to cooperation. The morphological differences between modern Homo sapiens and archaic human species, such as smaller brows and reduced jaws, might mirror the alterations we see in Belyaev's foxes: shorter muzzles, floppy ears, white-spotted coats. The exact parallels remain contested, but it's hard to ignore how neatly they align. Despite the exciting breakthroughs, important questions remain. Are the domesticated foxes truly dogs in fox form, or do they represent a unique midpoint between wild and domestic species? How would they fare if released into the wild? And does this approach to accelerated domestication carry ethical ramifications we have yet to explore? Through the decades, some critics have worried about the welfare of these selectively bred animals, especially during the Soviet era when resources were scarce. Others argue that turning foxes into pets might commercialize a genetic experiment that was originally meant to illuminate deep scientific truths. The project does indeed raise ethical quandaries. Once humans see how swiftly traits can change, might they be tempted to manipulate other species for superficial ends? Meanwhile, conservationists wonder whether advanced breeding programs could rescue endangered species. Could we re-engineer certain behavioral traits to help threatened animals adapt to environments compromised by human activity? Belyaev's experiment suggests it's possible, but not without careful thought about consequences. Domestication is not just about being tame, it also involves rewriting the biological blueprint from stress reactions to social bonding. Even today, research continues in Novosibirsk, albeit in smaller labs and sometimes with limited funding. Each new generation of foxes provides a fresh window into how domestication evolves. Genomic mapping has advanced, and many lines are carefully tracked to ensure the data remain rigorous. Whether we should or should not replicate this rapid domestication in other contexts remains an open debate, shaped by practical, moral and scientific considerations. One might ask, what's so special about breeding for friendliness? The deeper lesson is that tameness can function like an evolutionary gatekeeper. By selecting for animals that accept human presence and even crave it, Belyaev tapped into the genetic architecture that underpins mammalian sociality. Once that gate swung open, a flurry of traits, both physical and mental, came spilling through, recasting foxes as creatures that could curl up for a nap in a human's lap. This phenomenon pushes us to reconsider what else might be possible through highly targeted selection. Could we nudge a wolverine population toward docility if we had the time and the control? Could we coax certain forest animals to adapt to urban living more rapidly, easing habitat conflicts? Philosophers, biologists and ethicists alike continue to grapple with the power this experiment showcases. The lesson resonates far beyond fur farms or the Siberian wilderness. It's a testament to the adaptability baked into living systems and the potential pitfalls too. When you alter genetics, even for beneficial ends like tameness, you're nudging entire developmental pathways, possibly affecting immune systems, lifespans, and mental capacities. The rapid domestication of the silver fox reminds us that evolution is not a static relic of the distant past. It can be wielded for better or for worse, whenever humans intervene in reproduction. In a place renowned for its brutal winters and government censorship, Dmitry Belyaev dared to question one of biology's most ingrained assumptions. He dreamed of seeing an evolutionary leap in his own lifetime, a dream that the world's leading experts thought impossible. Through patient breeding, meticulous observation, and a touch of subterfuge, Belyaev and his team condensed centuries, if not millennia, of domestication into a matter of decades.